Hey there, today we're going to be doing Jump Game 2, which is the extension of Jump Game 1, so make sure to do Jump Game 1 first, don't forget about that. Um, the difference between this and Jump Game 1 is that we're always guaranteed that we can reach index num minus 1, n minus 1, so there's always a solution basically. We're not checking for the validity of the array, we're checking what's the minimum number of jumps that we can do to reach the end of the array. So I have here a visualization essentially of the approach that we're gonna do. It's basically just simple greedy. So almost the same with the approach we had for Jump Game 1. But here we already know what we already know that there's already a solution, right? So we're just going to maximize the amount of jumps we can do per iteration of our algorithm. So here we have the algorithm, or sorry, we have the first element here is 2, right? So this represents either 1 jump or 2 jumps. And we're just going to check the entire range of jumps by essentially keeping partitions. So you can imagine this as sort of one partition or one interval even. So if you've done intervals before, if you haven't, it's fine, but you can just visualize this as like one partition of, okay, so this is the range of, this is the box that we can generate out of this. So what I mean by that is this is the amount of, this is the indices that we can reach from this particular index, right? This particular jump, we can either go 1 here or 2 here, right? And so this is very important just to understand that basically what we're trying to do is we're just checking for the range of elements that this index can get to, and then we find here what's the max, right? And the max here is 3. And we just check for the entire array, right? Or sorry, for the entire box, the max here is 3. And then we set that as the new index. So here the max is either 1 or 3, or sorry, the max is either 2 or 4. This is the new box we have. So it's either 2, 3, or 4, right? So this is the new box that we generate right here. And then, oh, we found that the max is inside, or sorry, the end of the array is inside here. So we just return the number of jumps that we have done, basically. So obviously here we've just checked the first index and the second index, right? So that would be 2. And maybe I just give you one more example. Let's say it's 12. And then we just have a number of elements here. And let's say 3. So here, the interval, or the box that we're generating for ourselves, is 1, 12. So index 1 through to index 12, let's say there's just 11 other elements here. Index 1 to index 12, this is the amount of indices that we can reasonably get to, right? We can either jump 1 time, 2 times, 3, 4, so on, 12 times, right? And we just iterate through this entire box to find what's the max here. Because who knows, there could be a max here. Maybe there's, I don't know, 12 here, another 12. Maybe there's 14 here, or 20 here. We never know. It's inside the range, so it's reachable. We just have to find, okay, so here is the amount of indices, or amount of jumps we can reach to. What's the max here? If it's 20, then okay, we're just going to make another range, so whatever index this is in, so let's say it's at index 5, so we can go to 26 all the way to, what's the max? Oh, sorry, we can go 5 to 26 basically. So that includes this and a new box all the way to 26th index essentially. And we just check the same thing and then find the max, and okay, so if it's equal to n minus 1 or the length of the list, then we return the jumps. That's basically the algorithm, and we're gonna code this up. I'm going to just redo this because the recording was kind of cooked just now. So starting off, we're going to just do a variable to return that expects an int, so it's going to return jumps. It's just going to be at the end of the algorithm. And how do we check for the starting and ending of the box? We just use two pointers. We can say left is 0. This is the min. Right equals to 0. This is the This is the max. What's happening to my Vim? This is the max. Why is this highlighted? What the heck? Okay, whatever. Left is 0 and right is 0. So this is the min and max. Obviously, at the first element, we're just starting off with the first element. So our box is just this big, basically. Oops, sorry. So what's the loop invariant now? And what loop should we use firstly? Well, we're going to use a while loop because we're going to jump through the array to check for to generate the partitions. So a for loop wouldn't work, basically. So while right is less than len nums minus 1. So unless we found the solution already, we're going to keep on iterating. Firstly, we want to check for the maximum reach, and this is to determine what our next starting partition is, right? So in here it's let's say it's just 20, right? Or sorry, this is to determine what the next end partition is. So we just want to check over this range what the max is, so we can check for the maximum of the new partition, or the end of the new partition, right? So we're just going to say it's just the max jump. Max jump we're going to set to 0 for I in range left, comma right plus 1, obviously because of just inclusivity with the end index. We're going to do max jump equals to max jump, or sorry, max jump, max jump, and the I plus nums I, basically. If you're not familiar, this is just the sort of just to check what's the reach, right? So if this is 20, it's just 5, which is the current index, plus 20 is 26, or 25. Yeah, this is just the maximum index that we can reach with the current jump plus what that jump is in the index, where that jump is in the index. And now we're going to generate the new partition, so that once we loop through it again, we can check the new partition. So what should be the left and right partitions here, or the left and right boundaries here? The left boundary is going to just be the right boundary plus 1, right? Because we've already looped through the, actually this drawing is a bit wrong because we've already looped through all these elements, so we can just check the right boundary here, basically. Yeah, it's just a bit of a mistake. Oops. So this is the new right boundary, which is just the new left boundary, which is just the r plus 1. So the previous right plus 1. And then the right boundary is going to be our max jump, because well, obviously we want to check the max that we can reach. We want to maximize our box as big as possible, right? Okay, so we have left equals to right plus 1, right equals to max jump. These are the new partitions. This is the min and the max. We're just going to do jumps plus equals to 1. And let's run these test cases really quick, just to verify our answer. And this should just be the solution right here. Unless I'm tripping. Yep, that's Jump Game 1. Thank you for watching. Bye-bye.